Right now, as you watch this video, there's a massive wave rolling through our galaxy. It's pushing billions of stars out of their positions, and scientists have absolutely no idea what's causing it. But that's not even the strangest part. At the very edge of the Milky Way, nearly 2 million light-years from where you're sitting, astronomers have discovered something that shouldn't exist. Stars that are older than the galaxy itself. Structures that look like scars from ancient cosmic violence. And rivers of stars that are the remnants of entire galaxies that our Milky Way has consumed. In the next 15 minutes, I'm going to show you discoveries so recent that most of them were made in the last year. And by the end, you'll understand why what's happening at the edge of our galaxy might reveal the ultimate fate of everything we know. For most of human history, we didn't even know we lived in a galaxy. And for decades after we figured that out, we had no idea where our galaxy actually ended. Think about that for a second. We're living inside something and we don't know where its boundaries are. It's like being trapped inside a snow globe and trying to figure out where the glass is while you're still inside it. But in 2020, a team of astronomers finally found it. They discovered that the Milky Way stretches nearly 2 million light-years across. That's more than 15 times wider than the bright spiral disk you see in pictures. Here's how they did it. They used computer simulations to model how giant galaxies form, specifically looking at cases where two massive galaxies grow side by side, like the Milky Way and our neighbor Andromeda. Then they looked at the speeds of small galaxies orbiting near the Milky Way, and they found something remarkable. At about 950,000 light-years from the galactic center, the speeds of these satellite galaxies suddenly dropped. That marked the edge, where the Milky Way's dark matter halo ends and empty intergalactic space begins. To put this in perspective, if you could shrink the distance between Earth and the Sun down to just 1 inch, the edge of our galaxy would be 4 times farther away than the Moon actually is from Earth. So what exactly exists out there at the edge? What are we actually looking at? The answer is haunting. We're looking at a graveyard of galaxies. The outer halo of the Milky Way is like a cosmic crime scene. It's filled with stellar streams, these long, thin ribbons of stars that stretch for thousands of light-years across the sky. And every single one of them is the remains of a smaller galaxy that got too close to the Milky Way and was literally torn apart by gravity. Imagine a smaller galaxy, maybe containing a few million stars, peacefully orbiting around the Milky Way. But over millions of years, the Milky Way's immense gravitational pull starts stretching it, pulling it apart like taffy. Eventually, the entire galaxy gets shredded, and its stars get strung out in a long line that traces the orbit it once followed. Astronomers have found dozens of these stellar streams. The most dramatic one is from the Sagittarius dwarf galaxy. This smaller galaxy is still being torn apart right now, in real time. Its stellar debris is spread across an enormous area of the sky, wrapping around our entire galaxy like a ribbon. But here's what's shocking. Recent surveys using the Gaia space telescope suggest there could be close to 1,000 of these streams in just the inner 75,000 light-years of the Milky Way alone. That means our galaxy has consumed hundreds, possibly thousands of smaller galaxies over its lifetime. We're living inside a cannibal. And those ancient stars at the edge, the ones older than the galaxy itself, they didn't form in the Milky Way. They formed in those smaller galaxies billions of years ago, before being absorbed into our cosmic home. Now let's talk about that wave I mentioned at the beginning. Because this discovery is so recent, the scientific paper was just published in October 2025. Using data from the Gaia space telescope, astronomers discovered something unprecedented, a giant wave pattern rippling through the Milky Way, affecting stars between 30,000 and 65,000 light-years from the galactic center. Think of it like doing the wave at a stadium. Individual people stand up, raise their arms, then sit back down. But when you zoom out, you see this beautiful wave pattern moving around the stadium. The same thing is happening with billions of stars in our galaxy. The stars are moving vertically, bobbing up and down relative to the galactic plane. And this motion is shifted slightly sideways compared to their positions, which is exactly what you'd expect from a wave propagating through space. The waves are enormous. It affects a vast section of the galactic disk, and its influence can be seen across tens of thousands of light-years. Here's the mystery. Scientists have no idea what caused it. One possibility is that it's related to the Milky Way's warp. Our galaxy isn't flat like a dinner plate. It's actually warped, bent like the brim of a fedora hat. And this warped disk slowly oscillates over time, kind of like a spinning top wobbling as it spins. Another possibility is that the wave was triggered by a close encounter with a satellite galaxy. When a smaller galaxy passes near the Milky Way, its gravity can send ripples through the larger galaxy's disk, like dropping a stone in a pond. Or it could be something we haven't even thought of yet. What makes this discovery so compelling is that we can measure not just where the stars are, but also how they're moving. The wave isn't just a visual pattern, it's an actual physical motion of billions of stars, all moving in a coordinated way. And it's not the only massive structure we've found. There's also the Radcliffe wave, a smaller but still enormous filament of gas and young stars that stretches for 9,000 light-years and sits just 500 light-years from our sun. These waves might be related, or they might be completely different phenomena. But here's where things get truly wild. Not only is the Milky Way pulling things in, it's also throwing things out. There are stars moving so fast that they're actually escaping our galaxy. They're called hypervelocity stars, and they're traveling at speeds that would blow your mind. Most stars in our galaxy orbit at around 220 kilometers per second. The sun is cruising along at about 450,000 miles per hour. That sounds fast, but hypervelocity stars are moving at over 1,000,000 miles per hour. Some are traveling at speeds approaching 1,755 kilometers per second. That's almost 4 million miles per hour. At those speeds, you could travel from Earth to the Moon in about 20 minutes. How does a star get moving that fast? The leading theory involves the supermassive black hole at the center of our galaxy, Sagittarius A star. Here's the scenario. Imagine a binary star system, two stars orbiting each other, that wanders too close to the galactic center. The black hole's immense gravity captures one of the stars into a tight orbit, and in the process, it slings the other star out of the galaxy like a cosmic catapult. The first hypervelocity star was discovered in 2005. Since then, astronomers have found dozens of them. And in 2024, citizen scientists working on the Backyard Worlds project discovered something extraordinary. The first hypervelocity low-mass star, a faint red subdwarf traveling at 1.3 million miles per hour. This discovery is particularly interesting because it's only 400 light-years from Earth, making it the nearest known hypervelocity star to us. And it's headed out of the galaxy for good. Recent data from the Gaia mission revealed something shocking. Hypervelocity stars are far more common than we thought. Astronomers have identified 591 high-velocity stars, and 43 of them of those, they are moving fast enough to eventually escape the Milky Way. Think about what this means. Our galaxy is slowly bleeding stars into intergalactic space. Over billions of years, the Milky Way is gradually emptying out. Now here's a discovery that came out just days ago. NASA scientists have found what they're calling a break in the Milky Way. Using the Chandra X-ray Observatory, researchers discovered a 230 light-year-long filament in our galaxy that's been deformed. This structure, nicknamed the snake, is one of the so-called bones of the galaxy. Long, dense filaments of gas and dust that help reveal the positions of stars and other objects. What happened to it? Evidence suggests that a pulsar, a rapidly spinning neutron star with an incredibly strong magnetic field, slammed into this structure at speeds between 1 and 2 million miles per hour. The collision bent and disrupted the filament, creating an irregular edge and uneven density. And here's what's significant. The deformation is recent enough that the galaxy is still shifting from its effects. This discovery has made scientists rethink their assumptions about how stable our galaxy actually is. If an important structural element can be easily broken, what else might be damaged or distorted? It's forcing astronomers to map out other parts of the galaxy with advanced telescopes to look for similar breaks hidden behind gas or dust. The Milky Way, it turns out, is far more dynamic and reactive to cosmic events than we ever imagined. So let's step back and look at the big picture. What do all these discoveries tell us? First, they reveal that the Milky Way has a violent history. Our galaxy has been consuming smaller galaxies for billions of years, tearing them apart and absorbing their stars. The outer halo is littered with the remains of these cosmic casualties. Second, the galaxy is far more active than we thought. It's not a static, unchanging structure. There are waves propagating through it, structures being broken and reformed, and stars constantly being ejected into intergalactic space. Third, these discoveries at the edge of the galaxy are giving us unprecedented insights into dark matter. You see, most of the Milky Way's mass isn't in stars or gas. It's in dark matter, this mysterious, invisible substance that we can only detect through its gravitational effects. By tracking how stars move at the edge of the galaxy, especially those hypervelocity stars escaping into space, astronomers can map out the shape and distribution of the dark matter halo surrounding our galaxy. This helps us understand what dark matter actually is, one of the biggest unsolved mysteries in physics. And fourth, these studies are helping us understand galaxy formation more broadly. The Milky Way isn't unique. The same processes we're observing here are happening in billions of other galaxies across the universe. In fact, using artificial intelligence and high-performance computing, researchers just created the first simulation that can track all 100 billion stars in the Milky Way individually. This breakthrough is helping scientists understand how galaxies grow and evolve over cosmic time. So where does this leave us? First, understand that most of these discoveries are brand new. The wave? October 2025. The break in the galactic structure? Just days ago. The first complete map of the galaxy's edge? 2020. We're living through a golden age of galactic archaeology, with missions like Gaia providing unprecedented precision in mapping stellar positions and motions, and with next-generation telescopes coming online, we're going to learn so much more in the next few years. But here's what keeps me up at night. Our galaxy is slowly dying. Not in a catastrophic way, but gradually. Stars are being ejected into intergalactic space. The rate new star formation is slowing down. Eventually, in the far future, the Milky Way won't just merge with Andromeda as most people know. It will also continue to bleed stars into the cosmic void. And here's the really wild part. In about 4 billion years, the Milky Way and Andromeda will collide. When that happens, all of these structures we've been talking about, the stellar streams, the waves, the carefully mapped edge of our galaxy, all of it will be scrambled and reformed into something entirely new. The galaxy we're studying today is temporary. It's just one snapshot in a continuous process of cosmic evolution that's been happening for over 13 billion years and will continue for trillions more. So the next time you look up at the night sky, remember, you're not just looking at stars. You're looking at the remains of ancient galaxies, at waves rippling through space, at stars escaping into the void. You're looking at a living, breathing, evolving cosmic structure that's far more dynamic and violent than anyone imagined just a few years ago. And we're only beginning to understand what's really out there at the edge.